Hey guys, Mrs. Traber here. Today we're going to talk about graphing quadratics from Vertex form. Your success criteria is you'll be able to identify h and k in the formula. Let's jump in. Our first I want to show you is Vertex form. So it looks like this: y equals a times the quantity x minus h squared plus k. What I want you to notice is in this formula, the vertex is actually the point hk. So when we look at this, we can see the h and the k right in the formula. That's why it's called Vertex form. The h, I notice, has a minus in front of it, which means that when we look at the vertex form, you kind of look at like the opposite of what number that is, and that's what you use for h. The k has a plus in front, so take the regular k. Let's look at these two and see if we can find the vertex for each. The first one, I'm just going to layer on top of it the original formula, which is a times the quantity x minus h squared plus k. And then we can notice that negative h is negative 2. That means h is 2. And then k is negative 5. So in this case, we have 2, negative 5 for our vertex. The next one, as a reminder, it goes negative h, positive k. So that means since negative h is positive 4, that means h is negative 4. K is 3. Let's see what we can do if we want to graph them. So on this one, I can see the vertex right off the bat. Negative 3 is inside the parentheses, so I'm going to take regular 3 and then negative 1. So my vertex is at 3, negative 1. And I just want to put a point to the left and the right of it. So to the left of 3 is 2, to the right of 3 is 4. Let's plug that in. 2 minus 3 quantity squared minus 1. 2 minus 3 is negative 1. Negative 1 squared is 1. 1 minus 1 is 0. Since this is a vertex, on either side it's symmetrical. So this is also 0. So I've got a point at 2, 0 and 4, 0. And I can plot my quadratic. Let's look at the next one. Same thing here, but different point. So my vertex in this one is negative 4, negative 4. I can plot that, negative 4, negative 4. And let's go to the left at negative 5 and to the right at negative 3. If I plug that in, I have negative 5 plus 4, quantity squared, minus 4. Negative 5 plus 4 is negative 1. Negative 1 squared is 1. 1 minus 4 is negative 3. This is symmetrical, so this one's also negative 3. Negative 5, negative 3, and negative 3, negative 3. And I've got my quadratic. All right. What if, though, we are given it in vertex form and we're being asked to put it into standard form? In this case, we just need to simplify. With simplifying, as a reminder, we are working with PEMDAS. First, dealing with parentheses, there's nothing to simplify within the parentheses, so I have to do the exponent. The exponent is a quantity squared, so I'm going to write it out twice so that I can FOIL it. Let's do that next. When I FOIL, I'll get x squared minus 2x plus 4. I can combine some like terms. I get x squared minus 4x plus 4. So I'm done with the exponent. Next, I'm going to multiply the 3 in. That's the distribution. Y equals 3x squared minus 12x plus 12x minus 5. Multiplying and dividing are done. Last is add, subtract. So I'm just going to combine like terms. Y equals 3x squared minus 12x plus 7. I am now in standard form. Let's do one more of those. On this one, like we said, the first thing we do is get rid of the squared, so I'm going to FOIL it. There is a shortcut in this part that I want to mention, is when you have a quantity squared, what you can do is square the first thing, square the last thing, and then multiply these two. 4 times x is 4x, and multiply it by 2 to get 8x. That's the shortcut. So again, square the first, square the last, multiply the 2, and then double it. If you're not sure how that works, then let's work it out the long way. We have x squared plus 4x plus 16. And you can see the two 4x's, that's how the 8x comes to be. And the 16 is from the L. So when I simplify, I have what I started with there on my shortcut. Then I can distribute the negative 2. And lastly, combine these two like terms to get my final standard form, negative 2x squared minus 16x, minus 29. All set? The last thing I want to look at is something that leads us into the next video actually. What if we were trying to factor to find the roots? We've done lots of factoring problems before, but in this one, if I go to try to factor, I'd be looking for two things that multiply to be -7 and add to -3. The only ways to make a 7 are 1 and 7, and that doesn't make a 3. There are some that are called unfactorable, but it doesn't mean they don't have roots. In the next video, we will look at discriminant and quadratic formula and see what happens on those type of problems. I'll see you next time. Bye, guys.